Welcome, dear learners. Today I'm going to discuss about the zoogeographic realms of the world. So let's get started. Zoogeography, a vital branch of biogeography, focuses on studying the global distribution patterns of animal species and the factors influencing them. The concept of zoogeographic or faunal realms was first proposed by Philip Lutley Sclater in 1858 and later redefined by Alfred Russel Wallace in 1876. These realms represent vast biogeographic regions that exhibit unique combinations of animal life, each shaped by evolutionary history, continental drift, and climatic variations. Understanding zoogeographic realms helps us to explain how species evolved, dispersed, and adapted to different environments, offering crucial insights into biodiversity, speciation, and the historical development of ecosystems across the planet. The classification of world into zoogeographic realms is primarily based on several key biological and geographical factors. The foremost criterion is the presence of endemic fauna, referring to unique species and genera found only in specific region. Evolutionary history also plays a crucial role as continental drift and prolonged isolation have shaped distinct faunal patterns over time. Additionally, climatic and ecological barriers such as oceans, mountains, deserts, and glaciers restrict animal movement and gene flow between regions. Lastly, adaptation and speciation processes resulting from isolation have led to evolutionary divergence, giving each realm its characteristic animal assemblage. Biogeographers have classified the Earth into six major terrestrial zoogeographic realms, each characterized by unique animal groups and evolutionary histories. The Palaearctic realm includes Europe, Northern Africa, and Northern Asia, featuring bears, wolves, and musk ox. The Nearctic realm, covering Northern America, is the home to bison, raccoons, and the mountain beaver. The Neotropical realm of South and Central America exhibits immense diversity with species like sloths, jaguars, and macaws. The Ethiopian or Afrotropical realm includes Africa south of the Sahara, hosting elephants, giraffes, and lemurs. The Oriental realm spans South and Southeast Asia with tigers, gibbons, while the Australian realm is distinct for its marsupials and monotremes like kangaroos and platypus. The boundaries between zoogeographic realms are often not distinct but form transition zones where the fauna of adjacent regions overlap. These areas reflect gradual ecological and evolutionary blending rather than abrupt changes. Among the most biogeographic boundaries is Valence's line, which separates the Oriental and Australian realm, dividing Asian fauna, that is Borneo Bali, from Australian fauna, Sulawesi and Lombok. Further, east lines Weber's line, indicating a deeper transition in species composition, while Lydekkers' line mark the boundary of true Australian fauna. These lines highlight ancient geological separations of oceanic barriers that limited species dispersal, shaping the distinct evolutionary histories of regional animal communities. The historical development of zoogeographic realms is closely linked to theories of plate tectonics and the movement of continents over geological time. During the Mesozoic era, the supercontinents Pangaea began to break apart into two large land masses, Laurasia in the north and Gondwana in the south. This continental drift gradually separated species population, creating geographic isolation that prevented interbreeding. Over millions of years, this isolation fostered independent evolutionary pathways, giving rise to distinct animal groups in different regions. Consequently, each continent developed its own characteristic fauna, leading to endemism, where certain species evolved to exist only in specific parts of the world. In addition to terrestrial regions, zoogeography also encompasses marine and freshwater realms, which host a distinct aquatic fauna shaped by physical and ecological boundaries. The marine zoogeographic realms are broadly divided into Arctic, Atlantic, Indo-Pacific, and Antarctic zones, each characterized by unique temperature regimes, salinity levels, and species composition. The Indo-Pacific region is particularly rich in coral reef biodiversity, while Antarctic hosts cold adapted species. Freshwater realms, on the other hand, correspond closely to major river basins and continental divisions, influencing the distribution and evolution of fish, amphibians. Isolation of freshwater systems often promotes high level of endemism and adaptive diversity. The study of zoogeography realms hold great importance in understanding the distribution and evolution of animal life on Earth. It provides valuable insights into evolution and speciation, demonstrating how geographic isolation fosters diversification among species. From a biodiversity conservation perspective, identifying realm rich in endemic species helps to prioritize areas for protection and sustainable management. Zoogeographic knowledge also supports biogeographical studies, aiding in ecological niche modeling and predicting species responses to climate change. Additionally, paleobiology and ecology, it helps to trace historical patterns of migration, adaptation, and extinction, offering a deep understanding of planet's evolutionary and ecological history. Modern biogeographic research, particularly the work of Holt et al. In 2013, published in Science, has redefined the classical Valencian system using genetic and phylogenetic data. This updated classification recognizes 11 biogeographic realms, that is Nearctic, Neotropical, Palaearctic, Afrotropical, Indo-Malayan, Australasian, Oceanian, Antarctic, Panamanian, Madagascan, and Saharo-Arabian. Unlike earlier models based primarily on species distribution, this approach incorporates evolutionary relationships and molecular evidence to depict more accurate patterns of faunal lineage and divergence. The Valence-Holt system provides a modern framework for understanding global biodiversity, emphasizing the evolutionary connections among regions and enhancing conservation and ecological research at global level. To wrap up with, and a summary of the lecture is that zoogeographic realms represent natural divisions of Earth's surface defined by the distribution and diversity of animal life. Their formation is the result of historical isolation, climatic variation, and geographic barriers such as oceans and mountains that restricted species migration, and encouraging independent evolution. These realms reflect the deep evolutionary history of life on Earth, highlighting the patterns of speciation and endemism. Modern genetic and phylogenetic studies have defined traditional classifications, offering a clearer understanding of global faunal relationships. Recognizing and studying these realms is essential for biodiversity conservation, evolutionary research, and ecological management and planning worldwide. Thank you for watching.